Welcome back, Algebra Express. We are in Marecek 3.3. So this section is called Find an Equation of a Line. So in this section, they're going to give us basically two equations of a line, and we'll talk a little bit more about them. And so it says both of these formulas are used for creating equations of lines. Choose the one that matches the information you have. And so let's talk a little bit about these. So this is called slope-intercept form. And if we look here, we see an M. So M is our slope. And our B is our intercept. More specifically, our y-intercept, and it looks like it's in the form, it's the point 0, b. And so I think this one is the one that, like, if you fell asleep in class and I woke you up suddenly, you'd probably just like recite this formula to me, y equals mx plus b. I don't think a lot of people have difficulty remembering this one. It's just like one of those things that's almost ingrained at this point. So I don't want to spend a lot of time talking about this, but if we have a slope and we have an intercept, this is like our starting point. We can graph an entire line based off of like a sort of stair-step sort of thing that we do, right? And I believe we did that last section. And so this other one is called point-slope form. And so you might notice, let me go the right pen. We have our slope, our m. And instead of an intercept, we have a point, right? And we have a point that looks like x1, comma y1. There we go. And so a little bit about the difference between these. They both have a slope, but this one takes a point, and this one takes a y-intercept. So maybe you're asking yourself, like, what's the difference between that? So one way to say it, I think, is that a y-intercept is a point, but a point doesn't necessarily have to be a y-intercept. So this is more generalized, so we can always sort of go to this point-slope form. But we may not be able to go always directly to slope-intercept. So they have to actually give us a very specific point called the intercept, called the y-intercept, in order to go straight to this one. So what we're going to end up doing is probably plugging things into this one and doing algebra to solve for the other one. So if I ask you to solve for slope-intercept form, another way of saying that is to solve for y, right? It's like we're solving for y. Y is on one side, everything else is kind of on the other. Okay. There is one other sort of form that might come up. They don't talk about it much in here. But the other sort of thing would be like standard form, right? And we do see a few equations. They just don't talk directly about like what they call the form. But it is called standard form. If we have some coefficient with an x plus some kind of coefficient with the y, and it equals to some sort of constant on the other side, right? Where a, b, and c are some sort of constants, x and y are the variables in this equation. So there should be some sort of number for a, b, and c. So I think some people maybe like have a difficult time remembering this point slope form. So to me, like the thing that I kind of is if I find my slope, I'm doing y to my over x to next one. And so this is if I had slope. If I have 2 points and I'm trying to find a slope, this is what it would look like. So if I want to generalize one of these points, y x minus x. So if I generalize one of those points, so now I don't have, now this is variable instead of a specific point. Now I have a sort of equation that's going to give me a line. And if I move this bottom thing over, this is being divided by x minus x1. So if this makes sense, go with it. This is kind of the way I see that sort of formula in my mind. It looks a lot like the slope formula almost, but they generalized one of the points and made it an equation of a line and moved that bottom denominator over. So I think maybe I might need to flip the sides, right? Y minus y1 equals m times x minus x1. So this is the way I sort of see it in my brain. If that helps, good. If not, try to ignore what I just said. So you'll see that. Sometimes another version that they might give you of this guy. So y1 over, some books will write something like x minus x1, y1 over plus y1 on the other side when you shift it over. This is the version that our book has, I believe. Okay, so we're going to go with this one. So set up these formulas a little bit. Let's get some examples in there. So find an equation of the line passing through 0, 6 with a slope of a minus 4. So if we want to find this, are we using slope intercept or are we using point slope is the first question. So we can go straight to slope intercept form. So what does it say? My slope is a minus 4. My intercept 0, b looks like b is going to be 6. And so we're looking at this equation equals mx plus b. If my m is a minus 4, and my b is 6, it should look something like that. Okay. So typically, this is the sort of answer your math professor would probably prefer. Technically, if you did the other one, it would probably be correct, right? You could do y minus 6 equals minus 4x minus 4. So you might want to do some cleaning up on this. You will get the same thing as this if you solve this for y, right? But technically, this is the same equation. It is an equation of a line, so they didn't tell me specifically to put it in slope intercept, which they probably should have done if they wanted this version, which is probably what they want. Because one of the problems with this sort of one, with these, with the point slope form, is that this requires a point and a slope, right? So we know the slope is always going to be the same, but what point are we going to pick here? Well, technically, there's an infinite number of points on a line, so technically there's an infinite sort of number of ways that you could technically write this and it still be correct. And so if you're a math professor grading things, that's probably not the best way to sort of grade through things, to have an infinite number of sort of correct answers that you have to check through. So this one has exactly one sort of form that it's going to come out in, right? There's going to be exactly one slope. There's going to be exactly one y-intercept for a straight line. And so this is going to be like the equation for a line and slope intercept. But there are multiple sort of equations we could write for this. We could go find other points besides that. That would be really kind of annoying, but we could do it. I did a lot of extra work for this one problem, so let's not do that. Let's go with number 2 and look at what it's saying. So find the slope intercept equation of the line passing through the point minus 5, minus 2, and a slope of 1/3. So this one, which formula are you going to use? Are you going to use slope intercept or are you going to use point slope form? So if you go with slope intercept, we know this thing is 1/3, but if we like try to plug in a b, I'm not exactly sure what you're going to plug in because they don't give us an intercept, right? And so this is the sort of thing, if we don't get the intercept, we're probably going to have to plug it into the other one. So the other one looks like y minus y1 equals x minus x1. This one is called point slope because it requires a point and a slope. And so we have a point x1, y1. This looks like our slope m. We do y minus y1, and y minus, and this is equal to 1/3 of x minus a minus 5. Okay, so I'm going to do a little bit of cleaning up real quick. So y plus 2 equals 1/3 x plus 5. And so I need to do some distribution now. So I do 1/3 x plus 5/3. It's x plus 5/3. And now what I have to do is I have to subtract 2 from each side. So this side is going to be y. This side I got to do a little bit of thinking on. This is plus 5/3. I want to subtract 2. I'm going to go ahead and just put that over 2/1. So I'm subtracting 2 from 5/3. So how do I do that? What do I got to do? Find a common denominator of what? 3. I'm doing that. Let me write the step in red so you can see it. Multiply by 3. And now I got this thing. This is 1/3 x plus 5/3 minus 6/3. This side is just y. All right, I'm almost there. Y equals 1/3 x. This is 5/3 minus 6/3 should be minus 1/3. 5 minus 6 should give me a negative. And this is our equation in slope-intercept form. So this is typically the thing we want. It is the more sort of descriptive like form, right? It is very specific. We know the slope and we know the y-intercept where it goes through. Okay. Where we at? So after we find this, the next thing they want us to do is to check this. So they want us to check it with the point, what is it? Minus 5 minus 2. So we found our equation. We want to plug minus 2 into the y. We want to plug minus 5 into the x. And see if this is correct. We're checking it. Question mark. True. Minus 5/1 times that. We can do minus 5/3. And we're going to subtract another 1/3. Is a minus 2 equal to what? Minus 5 and minus 1 is going to give me minus 6/3. I believe a minus 2 is, move it up a little bit. Oh, not too much. And I'll get it right eventually. Here you go. Minus 2. And so this one does check out. All right, where are we at? Number 2, plugged it in, we checked it. I believe we're at number 3 now. Okay. Oh, sorry about the little delay. Dropped a bunch of papers. I don't want to have to cut and edit that though. Okay, so let's look at this. So find the slope-intercept equation of the line passing through the points -2, 5, and -4, -3. So the two forms we have, let's bring them back up maybe. Can we put them right here? Our slope-intercept form and point-slope form. So we're looking at these things. You might notice these things both require a slope. So they both require slope. Where they are different is that one is a general point and one's an intercept, right? But they both require a slope. So it says find the slope-intercept equation of the line passing through those 2 points. And so they give us 2 points. If you want, sort of how we mark 2 points. So they give us points, so we can definitely plug it into point slope. They don't give us an intercept, so I don't think we're plugging it into this thing. So we're plugging it into point slope. So if I'm going here, I know I'm using point slope form, and I can plug in a point, but I might have difficulty with this. So before I do anything, I really need to find a slope. And so this is going to be probably the most work that we have to do in this section for finding an equation of a line. They will give you 2 points. And so if they give you 2 points, the first thing you should do, we need slope for either one we're using. So if you don't have a slope, finding the slope should be the first. So y2 minus y1 looks like -3 -5, and that is over where am I at? -4 minus the -2. That's -8, and I'm doing it -4. That's really -4 plus 2 over -2. I believe my slope should be 4. Okay. So now I have a point. I have 2 points actually. But I'm going to look at this first point. I'm going to go ahead. So y minus 5. I'm doing x minus x1 looks like x minus a -2. This looks like y minus 5 equals 4, and I'm going to go ahead and change this to x plus 2. So I need to do some distribution. Y equals 4x plus 8. And now I need to add the 5 to the other side. So y equals what? 4x plus 8 plus 5 should give me plus 13. Okay, so let's recap. This is probably going to be the most work that they'll make you do in this section. So if we have 2 points, we don't have a slope. So if you don't have a slope, the first thing you need to do is find the slope between your 2 points. After you find the slope between your 2 points, we have point slope form. I almost said the wrong thing. We have point slope form we can plug it into. We can plug in our point. We can plug in our slope. And so I plugged in that point. So another thing you can do, and you can check this, there's another point there What happens if we plug in the other point? Four times x plus 4. So we plug in the other point and solve for slope-intercept. We should be getting the same slope-intercept form. And this is kind of what I was talking about earlier. So this is an equation. This is the same line in point slope. This is the same line in slope-intercept. This is the same line right here in point slope. This is the same line in slope-intercept. So point slope can always look sort of different depending on what point you pick on. But slope-intercept will always look the same. There's one sort of standard way to write slope-intercept for a line, right? Okay. So we have our line 4x plus 13. The next thing they want us to do is to plug in our 2 points to check this thing. So we have 2 points, minus 2, 5. And we have the point minus 4, minus 3. And so we're plugging this into this equation to check it. So my y should be 5. And this is equal to 4 times 2. 4 times a minus 2 plus 13. This one is, my y is a minus 3. And I'm checking that with 4 times a minus 4, and I'm adding 13. There's 2 things I got to check here. So let me do them one at a time. Let's not try to work them all at once. I did plug them both in at the same time. So 5 equals, this is 4 times 2 is a minus 8 plus 13. I believe this one is checking with 5 equals 5. When I plug in this one, minus 3 equals minus 16 plus 13. I believe that's giving me a minus 3 equals minus 3. So both of these should check out. And I'm doing class lecture notes. So hopefully they did check out. They should have. Following along with everything they're kind of setting up. You could have probably drew that conclusion a long time ago, right? Now for this one, they want me to do some graphing. So what I want to do is do a screen share, and I want to do some Desmos for this. I think Desmos is going to probably be the easiest way to do these. Okay. Let me get that out of the way, do a screen share. Let's go to some Desmos. Do a graphing calculator. Okay, so if I want to plot some points, let's do a table. Do x, y. We have a minus 2 with a 5, and we have a minus 4, minus 3. Zoom out maybe just a little bit. And then the equation we found was y equals 4x plus 13. And so we can see that line's going through these points. Does it look like 4x plus 13? It looks like, let's look up here, is going through the 13. So that is our y-intercept is 13. If we look at 4, and let's do steps to 1 without minor grid lines, and that'll help. So every 1 we go over, it should be going up 4. So we're at 5. So if we go over 1, it should be going up 4 to 9. That looks correct. Or if we go left 1, we should be going down 4 to 1. Okay, that looks correct. So we can sort of count these 1, 2, 3, 4, go over, 1, 2, 3, 4, go over, right? Or that 4/1 slope that's happening over there is what I'm talking about. Okay. So let's pop on back to the notes. And I believe we're done with that page. We are on the third page now. And let me get it straight on there. Here we go. Find the slope-intercept equation of a line passing through the point -1, -2, and perpendicular to that line y equals 1/3 x minus 2. So the last section we talked about perpendicular lines. So if you remember about perpendicular lines, we have to do two things to perpendicular lines. We have to flip the fraction and we have to negate it. So we have to put a negative sign on there. So if we know this is our first slope, we know it's perpendicular to this line. So perpendicular gives us information about slopes. And so if we know that this slope is 1/3, we know the line that's perpendicular to it is we flip this so it goes to 3/1, and we have to plug in a negative. So the slope I'm looking for my line should be a -3. And so now I'm looking, can I plug this into slope-intercept? They want the slope-intercept form. Do I have an intercept is what I'm asking. So I have my slope from the equation of this line. I know it's perpendicular to this line. The slope of this line is 1/3. The perpendicular line slope is a -3, -3. And I have a slope, I have a point, I don't have an intercept, so I have to go to point slope. So y minus y1 equals m times x minus x1. This looks like y minus 2 equals m minus 3 x minus a minus 1. Clean up my double negatives right quick. Y plus 2 equals x plus 1. Pretty soon I'm probably just going to stop writing double negatives and just start jumping to that plus. One of these days, we'll get there. Y plus 2 equals. I have to do some distribution here, so -3x minus 2. And the last thing I have to do here is I have to add 2 to both sides. Let me keep it going down. I got to subtract 2 from both sides, sorry. So y equals -3x minus 5. Okay, and then the next thing I ask us to do is check your answer by graphing your line and the given line on the same grid. Do the lines appear perpendicular? Does your line pass through -1, -2? Okay, so there's 2 lines we have to graph, and there's a point we have to graph. So let's look at this thing. Let's go back to Desmos, share my screen. Okay, share my screen. So the point we're graphing is -1, -2. There are 2 lines we're graphing. The first one looks like y equals 1/3 x minus 2. And the other one looks like y equals a -3. The one I just found, -3x minus 5. Okay, so the blue one is the one I just found. It looks like it goes through what? -1, -2. It goes through that point. The other thing, the red one was the one that they gave us. So these two, they're asking, do they look perpendicular? So these two lines, they look pretty roughly perpendicular to me. Probably exactly perpendicular since it is a computer. If I drew them, they would be roughly perpendicular. So those look perpendicular. The blue line, which is the one that we found, is perpendicular and it goes through the point. And if you think about it, there's only going to be one such line that's perpendicular that goes to that point. That's proofs left up to something else there. Okay, so it looks like it has all the things we're looking for. Let's go back to this problem. So we graphed this thing, we did it with the computer. It looks a lot prettier than if I would have done it by hand. So now we're on this one. Find an equation of the line passing through the point 3 minus 4 and parallel to this line. Come up with a way to check your answer. Okay. Okay. So we want it to go through 3 minus 4, and we want it to be parallel to that thing. So they give us a point. They don't give us an intercept, so we're going to have to use point slope is the thing I'm trying to say. We're going to have to use point slope. We have a point. We need a slope, and we're going to get our slope from the fact that it is parallel to this line. So in order to get the slope, we need to get the slope from this thing. If you get the slope from this thing in this form, I'm not sure what to say besides good work on you. I would not do it that way. So what do I want to do to get the slope for this thing? I want to solve it for y and get it in that slope-intercept form. If I get things in slope-intercept form, it's a really pretty form. I can get my slope right off of that thing. I can get my intercept right off of it. And it's the same thing as saying solve for y, right? So I want to solve this for y. 2x plus 3y equals a -9. I'm solving this for y. I'm subtracting 2x, 3y equals, I'm going to lead with the 2x, the minus 2x, and do -9. Now I'm dividing everything by 3. I have to divide this by 3. I'm dividing this entire side by 3. So there's two things on that side I have to divide by 3. This is my y. This looks like a -2/3 with an x attached. And this looks like 9 divided by 3 is 3. And this is my first slope. So the first slope of this line is a -2/3. If I want the line that is parallel, we talked about this last section. So if two things are parallel, they have the same slope. So maybe it's silly that I wrote it as two variables because it's the same number. It's the same thing, right? So we're taking the same number. We're taking the slope off of this thing. We know our slope is a -2/3. We know the point we want to go through they give us is 3 minus 4. So we have our slope. We have our x1, y1. We're plugging it into point slope. So y minus y1 equals m times x minus x1. So plugging in numbers, y, I'm just going to jump to y plus 4 equals my m here is a -2/3. And this looks like x minus 3. So this looks like y plus 4. Move it up a little bit. Y plus 4 equals, I'm distributing this -2/3 on x. This becomes plus, two negatives make it plus 2/3 times 3/1 is just going to be 2. Now I'm going to subtract 4 from both sides. Y equals a minus 2/3. X plus 2 minus 4 should make that a minus 2. Okay. And so this is our solution to the line. So if we're looking at this thing, y equals a minus 2/3 minus 2, they want to know, they want us to sort of check that. Did it end up being parallel to this thing? So if we look at these two equations, this slope has a minus 2/3, and what we ended up with here was a slope of a minus 2/3. So it's parallel to that thing. It's parallel to the line. And the other thing they asked here, it's parallel to the line. Does it pass through the point 3 minus 4? So this is checking our solution. We're going to plug in 4 here, minus 2, 3, 3 here, and a minus 2, and check that. Ooh, said the wrong number. What is it? 3 minus 4. Ooh, that should fix it. And so that should check. I'm not going to do that. Y'all can go ahead and do that on your own. But it should give you a minus 4 equals a minus 4 when you plug it in. Okay, let's go on to the next thing. We found that. Number 6, I believe we're on. Ooh, so this looks like they combine the last two, I think, kind of, right? So find an equation of a line passing through the point minus 8, 3, and it's perpendicular to this line 2x minus 5y equals 70. So they're giving us a point, again. They're giving us a slope through this thing. So this is how we're getting our slope. So we need to know the slope of something that is perpendicular to this. And so in order to find something that's perpendicular to this, first we need to know the slope of this. So 2x minus 5y equals 70. We're trying to find slope. And how do we find slope of something that looks like that? Well, it's not easy to pick in this form, but we know a form that it is easy to pick in, called slope-intercept, that thing that you mumble in your sleep probably. So 2x minus 5y equals 70. We want to solve this thing for y. Minus 5y equals, I'm going to rewrite this thing. So I'm going to subtract 2x. And I'm going to add 70. The next thing I'm going to do is I'm going to divide by minus 5. So I have to divide by minus 5 here. I'm dividing this entire side. So there's two terms I have to divide by minus 5. If I do it here, I should end up with y. This is equal to, this is a negative over negative becomes positive 2/5 x. This is negative overall. 70 divided by 5 is going to give me, what, 14. And so we did a little bit of work, and we did that little bit of work to do something. We did it to pick off a slope. So this guy's slope is 2/5. The new guy's slope is going to be what? And reminding you, it asks for something perpendicular. So we're getting the slope from this guy. We're going to make it a perpendicular slope. So to make it a perpendicular slope, reminder, there's two things you have to do. You have to flip it and reverse it. Make it negative, right? So flip it and make it negative. This is the slope we're using. The point we're going to use is minus 8, 3. So this is like our x1, y1. So we're plugging things into point slope now. This is my point, this is my slope. Okay, so y minus 3 equals what? Minus 5/2 x plus 8. And so now I got to do some distribution. Y minus 3 equals minus 5/2 x. This I'm going to divide 8 by 2 is going to give me 4. Minus 5 and 4 is going to give me minus 20. And so the last thing I want to do is I want to add 3 over, so y equals minus 5/2 x. If I add 3 to this, minus 20 is going to become, what, minus 17. Okay. And so now we have an equation of a line that should be going through this point, and it should be perpendicular to this line. So we have the technology. We can rebuild this. We can make them smarter. We can make them faster. We can do all kinds of wonderful things in Desmos. So let's go to Desmos. Let's graph these things. I have the point minus 8, 3 is the point that it should go through. So minus 8, 3 is the point it should go through. This looks like the graph y equals 2/5. I'm going to do an x minus 14. So maybe I need to zoom out a little bit to find that. So that is okay. That is the line that they give me. This is the line that's supposed to be perpendicular. That's actually the equation they gave me. Well, this is what we can do too. Let's do it. 2x. Let's make sure we solve that, right? You can also just like you got the technology. You could just throw that in there. Oh, look, it's the same line, so we solved that correctly. So if you want to use technology to check your solutions, check how you solve things, that should have been the same line, and it was. So that was a good indicator that we did something correctly. So the next thing looks like y equals, and this was the line we saw for, minus 5/2. This had an x attached, and it had a minus, 17? Oh, look at that. It looks like it's perpendicular to that line. It looks like it's going through that point, minus 8, 3 right there in green. So it looks like it's everything it should be, right? Perpendicular and going through the point. Okay. I think we're getting near the end here. Not too many more. Okay. Come with a way to check your answer. We checked it graphically. That's pretty good. We could also plug in the point as we've been doing. That's also a valid way to check these things. Okay. So they want us to write these in slope-intercept form. That's the one you know. And they give us graphs. So really what I think they're asking us to do is to pick off M and to pick off B. And to pick off M, remember M is rise over run. So if we go up 1 and we go over 3, we've gone up 1 and we go over 3. So what you want to do is you want to pick 2 points that it actually goes through, probably. So those are 2 points it actually goes through. Those are 2 points it actually goes through. You can count them, do your little triangle thing, however you want to do it. We went through a whole section on slope. So you should be able to pick off slope. you should be able to pick off my b is a -3. And then when you have these two, I'm hoping you can throw these things together. Y equals mx looks like 1/3 x plus b looks like a -3. Okay, so this one is maybe a little bit more tricky, but we've gone through something like this. Maybe you don't know what you're saying, but you definitely know your b value here should be 2. It's going through the y-intercept at the value of 2. And if I look at this y equals mx plus b, you might know that this is a line y equals 2. So you might be asking, like, what about the slope? The next here. Well, we're going up 0 for every however many we're going over. So one way you can think about slope is how much is it going up and down. If it's going up, it's a positive slope. If it's going down, it's a negative slope. This is just flat. This is also like a 0 slope. So you could think of it as like 0x plus 2 if you really wanted to. But typically we would just write y equals 2. And so technically this is in slope-intercept form. Just my slope is 0 and you just don't see it, right? So y equals 2 is technically slope-intercept form. Okay, and so that is the final problem on this set. So I will see y'all in class soon, hopefully. Take care.